hello from Birkdale School. I'd like to say a few words to welcome our speaker today. Captain Alan Bean was born in Texas in 1932, and in 1963 he was selected by NASA to become an astronaut. He made his first flight into space on Apollo 12, piloting the lunar module and becoming the fourth man to set foot upon the moon in November 1969. He left NASA in 1981 to devote his life to painting and sharing with the world his experience of sights that no other artist is likely to see firsthand. It's a privilege to have with us one of only 12 men in history who have walked on the moon. Please join me in an enthusiastic welcome for Alan Bean.
Hello, fellow Earthlings. Hello, fellow human beings. Glad to be with you today. I'm glad to think about Apollo. I'm glad to think about the space program and talk about it a bit, because I feel that it's one of the programs that showed the best in human nature. It showed that 400,000 people could work together to achieve a common goal. It showed that a lot of people can overcome their egos and try to find a way to solve problems together. Now, I know your sports teams probably do that. Some people do it very well, others don't do it so well. But I think Apollo is a prime example of what humans can do if we really want to put our minds to it. So I'm glad to be here today to talk with you a little bit. I look out in the audience and think how lucky you must be to be at this school and have the opportunities that you have to get a foundation that will lead you into maybe being the best you can be. Being the best you can be is up to you, but maybe this gives you a head start or a chance to know that you can be, or find a way to be the best you can be. I live in Houston, Texas. That's my wife, Leslie. Those are two little puppies. The one on the left is E.T. Stardust, and the one on the right there is Moonbeam Mouse. So that's our happy family. I have two children, Clay and Amy. They're grown now, and they have children. And I have 8 grandchildren, the youngest of which is just entering middle school, Theodora. And then the oldest is just graduating from Virginia Tech University in Virginia, and she wants to be a vet, so she's trying to get now into veterinary school. So I can sympathize with you about the struggle that you must be having. It's a hard time. Where you are in your life, in my opinion, is one of the difficult times it was in my life. It was only later on that I began to see that, hey, I can do more than I thought I could if I'm willing to do it. One of the things that helped me a lot is when I was a boy, 10 years old or so, this was World War II was on, and I began to want to be an airplane pilot. I'd never been in an airplane, but I watched them in the movie theaters. And I thought, that looks like a lot of fun. I think I want to do that. And I was able to hold on to that dream as I went through high school, college, and then on to become a naval aviator. It's important to have a dream, if you've got them, and hold on to it. Very hard to do, because the person next to you doesn't have this dream at all. Doesn't understand why yours is so important to you. And sometimes your parents don't. They're sympathetic. Maybe your grandfather doesn't even like what your dream is. Don't listen to them. They've got their own dream. Let them worry about their dream. Hold on to yours. It's made all the difference in my life. I'll talk more about that as we go along. Now, every impossible dream, and that's what it was in 1960, how do we get men to go to the moon and get back alive? That was impossible. I was a Navy pilot then. I actually had become pretty good flying airplanes. I'd taken aeronautical engineering college because I wanted to be a better pilot. I was willing to pay the price to be as best good as I could be. What I've noticed is some people are willing, others are more than some are not willing. They say they're willing, but they're not willing to pay the price to be as great as they could be. So think about that. You've got to make up your own mind. Will you do what it takes to do the job? Well, I had, and so they picked me as an astronaut. And the reason they picked me as an astronaut is when NASA was thinking, what kind of guys are we going to get to fly to the moon? They said, well, probably the closest analog on Earth is people that fly high-performance airplanes, test pilots in the Air Force or Navy, Marines or something like that, because they fly the most difficult airplanes to fly, the highest performance airplanes to fly. Maybe we could take them and train them to fly a spaceship. So that's what I was doing, and I competed with a lot of people, and they said, let's take Bean, maybe we can keep him out of trouble and teach him how to fly spaceships. So here I am flying a T-38. That's the Johnson Space Center over there in Houston, Texas. When they talk about mission control, one of those buildings in the upper left corner is mission control. So that's where I spent a lot of my life, 18 years, 18 years there. Now, when we began to start thinking about going to the moon, we realized that we didn't have to know everything. No one can. We didn't have to know which way to point the rocket to intercept the moon 3.5 days later, 240,000 miles away, when it was going 2,200 miles an hour around the Earth. I was never smart enough to do that sort of stuff. Physicists are. They can figure. We hired a lot of them to figure out how to do it. We couldn't do that. We didn't know how to build a spacesuit. We didn't know, I didn't personally know how to do a lot of things. But maybe I could learn to fly the machine and do that job. So one of the things we needed to know on the moon was, how much weight can you carry around up there? Can you bend over? How much energy will you expend while you're doing this? So they put me in a spacesuit, and they gave me a 70-pound weight there, because on the moon I was going to carry an experiment that weighed 70 pounds. On Earth it weighed 420 pounds. I couldn't lift it up, obviously. But here I am with 70-pound weight, and that rig there is going to lift up 5/6 of my weight, so that I weigh 1/6 of what I do on Earth, and then I could simulate what I would do on the moon. They could measure what BTU expenditure I had as I worked, a lot of other things. So as they lifted 5/6 of my weight, well, you can imagine, they were lifting the suit, they weren't lifting me. So as they lifted up, I kind of settled down on the crotch of that suit, and it wasn't all that comfortable. So I said, wait a minute, I've had enough of this wedgie, let's come back down, let's repad. We padded the suit, we've done the best we could. One of the things about achieving dreams is you never achieve difficult dreams in one shot. What you do is you make a try at it, and then it doesn't work. But if you'll sit down and think about it, maybe you can make a second try at it that's a little bit smarter than your first one, because you did gain knowledge. After the second one doesn't work, you're even smarter. You can try it again. We know this. Most people give up about one or two. We didn't. We came down, we talked about it. I came back 2 days later, we had some different ideas. I tried it, still didn't work, it was too painful. Tried it again, tried it 3 or 4 times. One of the guys came up with the idea that if they filled the suit with water, I might float. Well, it's a good idea, except I'm standing up, and you don't float standing up, you've seen it. So even though it was an idea worth trying, it didn't really work. So we tried a lot of different things to pad it. We finally got something that was pretty good, not really good. But that was better than not doing it at all. Then we took a suit and put it underwater and had it buoyant to 1/6 gravity. That worked pretty good. but you're in the water, and that's not the same as in the vacuum of space. We tried suspending it and hanging it sideways where the cosine was 1/6. That was a good idea. It was fun to do. I can remember doing it and thinking, wow, this is fun. Well, all of these, none of them were perfect, but all of them added up so that when I got to the moon, it seemed pretty familiar. And the data we got was pretty close. Wasn't perfect, but as close as we could do on Earth. Well, they came to us while we were training and they said, look, we need to teach you what you need to know when you get to the moon. We know you guys are pilots and you like to practice entries and landing on the moon and the lunar module simulator. You like to practice launches and launch aborts and entries. You like all that stuff. You're doing it all the time. That's airplane stuff, pilot stuff. But if you're going to go to the moon and be an explorer, we've got to teach you what to do as an explorer. We said, we already know what that is. They said, well, what do you think it is? Well, we're going to get out of the limb, and then we'll pick up some rocks. We'll put them in a rock box. Then we'll put up the flags. We'll do that. We'll probably maybe talk to the president. Maybe we'll do some TV showing us running around or something like that so that people, scientists on Earth can see it, and then we'll come home. And they said, that's not what you're going to have to do as an explorer. You're going to have to get up there and make scientific observations about what's there and what it means and what's new about it from what we thought was there. We said, wait a minute, the only thing that's up there are craters and rocks. They said, that's right. So you're going to have to learn a lot about craters and rocks. We said, we don't want to do that. That's what geologists do. We don't want to be geologists. We're pilots. We don't like rock. They said, okay then, you're not going to be a very good explorer. And it took us 2 or 3 days to get our head on right and to decide, you know, if we're going to try to be explorers, we better get an improved attitude. We did. Okay, so we go into class, we sit in lectures just like you do. We go into laboratories, we study the rocks in thin sections, all this. We go to different parts of the Earth where they think it looks kind of like the moon, like in Iceland, or maybe Hawaii, maybe some places in Mexico or in the northern part of the United States. Not too many places in England look like the moon. So there's a place in Germany that does. So we knew this, our geologists knew it. Here we are, Pete and I working together. This is near the end of our training, and we're having all the equipment we'll have on the moon. We're not wearing our spacesuits, but right here is the tools. There's our camera. We've got radios just like our spacesuit. That's that thing right there. And so we're talking to our geology instructors. They're kind of behind the hill. And they even had a delay in the voice so that it was like it is on the moon, because it takes about a half a second or so for your voice to get to the moon and then another half a second to get back. And you'd think that would be disturbing, but it isn't. What it is you're just talking to somebody that thinks a little bit. So you say, okay, I just picked up this rock. What do you want me to do with it? They don't answer immediately, like if they were standing next to you. There's a little delay, and they say, we'd like you to put it in a sample bag or something. So it seems normal. And after a while, in the moon, it seemed normal, just like they were over the hill, except they were back 240,000 miles away. So anyway, here we are. So we'd be running through our simulation. We'd be picking up rocks, making comments. When it was over, then this geologist would come out from, our trainers would come out from behind the hill, and then we'd walk through it again. And they'd say things like, well, Bean, why didn't you pick up that rock? Now we said, well, you know, that rock looked the same to me as this one we picked up 10 minutes ago, sample number 12. And they said, well, it isn't like sample 12 because it has a different fracture angle. It has several other qualities that are different from the one back on 12. You should have picked it up. So we did the training, and then we went through it and tried to do it as we would on the moon. When we finally got to the moon, we were pretty good geologists. Weren't great, pretty good. I probably got the equivalent of a doctorate in geology, would be my guess. So, anyway, here we are. We didn't work all the time. And so Chevrolet comes to us and they said, look, you guys are giving your picture in the paper and the magazines a lot. If we loaned you cars, then our cars would be in the picture too. We said, that's okay, it's good. So they'd come to me and other astronauts when the new cars came out. And they'd say, Alan, we loaned you a red Corvette last year. What do you want this year? And I'd say, well, I've always wanted a black one. So, okay, we'll bring you a black one. So about a month later, a brand new black one would show up and I would turn them the red back. Excuse me. So anyway, it was fun. If you can imagine being 30 years old, which you can't, someday you will, 30 years old, and training to go to the moon, driving Corvettes, it was fun. It was fun. Anyway, we're all training to go to the Sea of Tranquility. We don't know which mission is going to get the chance to make the first attempt. So Apollo 11 rolls around. We've done everything we needed to do prior to going to the moon. So we say, okay, that's the crew that's going to make the first attempt. Neil Armstrong, Buzz Aldrin, and Mike Collins. So here they go off in July. We don't know exactly how it's going to go because there's so many unknowns, but we've done the best we can. So we've done everything the best we can, but there's still a lot of unknowns. And lo and behold, when Neil gets ready to land, this is a painting of mine with the lunar module up there. He's supposed to land right in here. You can see these boulders in here. He decided not to land there, so he overflows, flies, and lands just beyond, actually behind this crater. So anyway, he lands there, and they're on the moon. This is a painting I did of them putting up the flag. There's a painting of mine of the famous picture of Neil, but there's no picture of Buzz taking that picture, so I did a painting of Neil right there, taking that picture. I left the space program after my second flight, and then I did a backup flight, Russian mission. Left there because I said, I've been to the moon. I've been to a place that only 11 other people have ever been. And art was my hobby. I began to taking art in night school when I was a test pilot. Not to be an artist, but to be just as a hobby. And then the more I did it, the more I liked it. And I said, if I could learn to be better, then I could leave paintings like this behind long after I'm gone that will tell stories that would be lost forever. So that's kind of why I left. I love being an astronaut. I was training to fly the shuttle. But I said, there's a lot of young men and women there that can do it as good as I can, but I'm going to go do this. So took that shot. They came home. They came to us and they said, look, we're not going to send you back to the Sea of Tranquility. We're going to send you to the Ocean of Storms, where a spacecraft, unmanned spacecraft like this, Surveyor 3 landed 33 months earlier, and you're going to cut some parts off. So here we are training in a building at Cape Kennedy. It's inside a crater is where it's going to be on the moon, and the slope of the crater was 13 degrees. So we're training on a plywood platform that sloped 13 degrees here. Indeed, when we got to the moon, it was inside, the Surveyor was inside a crater, sloped at 13 degrees, just exactly like the scientists had predicted. And here we are. Here's Pete. He's got some bolt cutters. Here I am. I'm holding onto this camera, and he's cutting these stanchions. The reason we wanted the camera, the scientists back on Earth wanted the camera, was it had been in space longer than any other object, and that camera had optics and wiring and gears, lubrication, all this other stuff. We also cut off this scoop that had dug ditches into the moon, unmanned with commands from Earth. So we brought that back, and it's still with some dirt in it, matter of fact. Here's our rocket, so beautiful, 363 feet high, weighed 6 million pounds, had 7.5 million pounds of thrust back here. The most powerful machine ever built by humans, and it flew. That's what it took to get to the moon. This thing weighed 6 million pounds when it left Earth. When we came back in that little bitty, I can't reach up there, that little bitty cone-shaped command module, it weighed 13,000 pounds. That was it. All the rest was used as fuel or dropped away to get to the moon. Vibration, noise. I thought that thing was going to come apart. And when I said in my head, I wonder if it can withstand this shaking. By having that thought in my head, it made me about 3 or 4 seconds behind the job I was supposed to be doing. It was hard to catch up. That's what the Earth looked like as we left it. It didn't look like we were leaving the Earth. It looked like the Earth was going away from us. And I thought, you know, we've got to come back to this place. Here's Central Mexico right here, South America down here, United States, Baja California, North Pole up there, that's an ice cap, not clouds so much, Pacific Ocean. The moon is going around the Earth at 2,300 miles an hour. And the moon and the Earth are going around the sun at 66,000 miles an hour. So when we got ready to come back home, the Earth isn't going to be there. It's going to be a long, long way away. And the computers and mission control, with physicists who had to figure this out. And we had to believe that that part of the team could do it. They could find a way to get us headed home in the right direction, because we had like about a quarter of a degree that we had to enter in the atmosphere. If we entered too steep, we would burn up. If we entered too shallow, we'd skip out. So it was very precise that y'all had to do these sorts of things. Otherwise, I wouldn't be standing here. So we had confidence. Here's what the Earth looked like when I was going around the moon. Here we are coming in for a landing. I'm over on this side looking out the window using the computers and the light. Pete's on this side over here. He's flying it mostly. I can remember when I first looked out the window, when we were down, we were going maybe a couple thousand miles an hour. I remember looking out the window and thinking, boy, the whole place is covered with craters. There's no place to land. And I could feel my pulse rate go up. And I could feel excitement and fear a little bit. I said, I can't do my job if I feel this way. So I looked in the lunar module, and so I wasn't looking out, and then it looked just like it did on Earth when we trained. And so I felt my pulse rate go down, I felt my fear lessen, and so then I looked up. I was better, still a little bit excited, but we were lower and I could see some areas maybe we could land. I looked back in again, and next time I looked out, it was okay. So as humans, we're very adaptable. That's one of the nice things about being a human. We're very adaptable to what's going on. We can learn to walk in 1/6 gravity. We can learn to do something when we get back home in 1 gravity, and to maybe lie down or something like that, so that we get through the transition and then our bodies will adapt. So we can do those sorts of things. So anyway, we came in, Pete found a place. We were going to land on the near end of Surveyor Crater, the surveyor over there. Too many boulders. He flew beyond it and landed on the far corner. So that's where we landed. Here I am coming down the ladder. I'm taking my first steps on the moon. Now, when I became an astronaut, when I first went to, I was an astronaut candidate. And after a year of training, then I received a silver pin with a star on it and 3 little rays and an orbit around it. And I wore it on my coat or this jacket, and I had that pin right here in this pocket. And when first thing I did once I got my balance, it took 2 or 3 minutes, then I moved over near Surveyor Crater, and I took my pin, there it is, and threw it towards Surveyor. And that pin is up on the moon right now. In fact, when I think about the moon, I'll look up there, and I'll look to the center at the equator, and I'll look about 30 degrees west. You can't see this crater. This crater is 600 feet in diameter, more or less. Couldn't even see it with the best telescopes on Earth. But I know sort of where it is, and I think about that little pin. And I think, you know, that pin's just as shiny as it was the day I threw it up there 40 some odd years ago. And it'll be up there for millions of years until someone like you, or your friends, or your children go up there and pick it up and bring it back home. So there it is. They think our footprints will remain on the moon pretty much unchanged for millions of years. Now, if you make footprints out here, they won't last a week, probably, for rains. So you can see how different it is on the moon than it is here on Earth. It's different everywhere we've ever seen with our telescopes, with our robots we've sent out, explorers we've sent out in the universe. We've never seen any place like the Earth. We've never seen a place that had even a rabbit or a living thing, or a leaf of grass or a bush. We've got it all here. We don't seem to see it around the planets around our star. We're blessed. Running along the moon, that was fun. I felt real light. I felt real strong, because even my arms weighed less than they do right now. They only weighed 1/6. So when I moved my arms like that, it was like I was strong. If I thought about it a minute, I'd say, well, I'm in a light gravity field, but you don't. You're working away. You can lift things up you could never lift on Earth. You can jump high. It's fun. Many people will go up to the moon someday in the future as a place to go on vacation. And they'll have Disney Worlds up there. Someday they'll have the Olympics up there. They won't be doing it in a suit like this. They'll have domes. They'll go up there, and they'll, like Antarctica, they'll build a dome. We can do this now, size of this. Next time they go, they'll hook 2 or 3 of them together. And so we'll get a lot of space up there. Then the technology will improve, and we'll build a dome the size of a soccer field. No problem. Build that, pressurize it, and then when they do, they'll say, you know, why don't we have the Olympics up there? And they'll have it up there. And it's going to be fun. Sprints won't be very much fun, because you got to have good gravity to lean forward and then get traction. But high jumps are going to be fun. Also pole vault. So it's going to be different. These are things that are going to happen to future generations. Maybe not yours, maybe yours, I don't know. Sure to happen. Here I am with those experiments there, 420 Earth pounds, 70 moon pounds. Here I am, and when I got back home, I was going through the grocery store to get some groceries, and I saw this picture in this tabloid. Here I am right here. Now, we really didn't see any bones. Besides, that's not a dinosaur, that's a whale. That's the jawbone of a whale. So whoever did this little art business here didn't know what he was talking about so much. But we wanted to see ancient civilizations or something, or diamonds, something. We wanted to see something like that instead of just rocks. So Pete and I talked about this before we went. Pete says, let's take an arrow and let's just drop it at our feet. And then we'll take our TV camera and point it over here, talk about some crater or something. And then we'll do like this, and then point it over there and talk about something. And we'll hear from Mission Control, point that back at your feet. And of course, we didn't do that, thank God. Because I'll tell you, scientists would have really been mad when we got home. They are fun guys, but they don't go for playing around with science. So thank goodness we didn't do it. Good idea we didn't do it. Here we are, down 13-degree slope. There's Surveyor, there's Pete and I there. Get ready to cut off that scoop. There's the TV camera. Working as a team. How many people think they're a good team member? Show me. Let's see a show of hands. How many people in this audience think they're a good team member? Nobody? Everybody's not a team member? I would have raised my hand. I thought I was a good team member. Okay? Let me tell you a story. I'm in the lunar module one day, training, just before I went to the moon. And I'm saying to Pete, there's a kind of a period after we landed because they got to reset the simulator up to orbit again. So I say to Pete, you know that briefing we had this morning, that engineer that was briefing us, he's not a good team member. He says, why not? I said, well, he seemed to know his business, but the way he explained it to us was so convoluted compared to how we think that I'm not sure he's a good team member. And I looked over at Pete, and I thought Pete would say, well, Bino, that's a good idea, let's get him replaced. But he didn't. He said to me, maybe you're not a good team member. Okay? Think about it if your teacher or your best friend says, maybe you're not a good team member. It's not a good thing to hear from your boss. And I can remember backing up, thinking, he said, that's not true, I'm a good team member. He said, you don't know the first rule of being a good team member. I said, well, yeah. He said, what is it? I said, well, you've got to be loyal to the leader. That isn't it. You've got to stay focused on your goals. That isn't it. You've got, I told him 2 or 3 other things, but I've forgotten what they are now. But he said, that ain't it. I said, well, what is it? He says, if you want to be a good team member, you've got to find a way to care and admire the other members of your team. I said, you're crazy. I was in this meeting this morning with you, and maybe there was 30 people there. I know about 15 of them. I admire them, I like them, some of them I don't admire, I just know them. There's about 10 guys there, or 5 or 10 guys that I don't even know who they are. They come to these meetings, they don't say everything. Then there's 2 guys in that meeting I don't even like, because they always bring up things at the end of the meeting. They always want to argue about what everybody else agrees on. I said, I don't admire them. He said, that's your problem. If you want to be a good team member, and someday you want to be a good team leader, you better find a way to care about them and admire them. I didn't like that. It took me several days to kind of get back talking with Pete regularly, but I began watching the astronauts in the office, and I soon learned that was right. The ones that were the best astronauts, they did just what I described. I wasn't doing it because I didn't realize that's what they were doing. And Pete told me about it, then I watched, and I changed. I did better. So I started doing it. I found out if I didn't like somebody or didn't know about them, I just took them to lunch. After I took them to lunch, I got to know them, and I could pick out things I like. So it's something to think about. It's something that works, I believe. Everybody you know, if you decide to like them, you can find things about them you like. And that same person, if you decide to dislike them, you can find out things like that. By the way, this is true about your mother and father. This is true about your brother and sister. You got a choice to make. And the choice is this: am I going to think about the stuff I like about them, or am I going to think about the stuff I don't like? My advice to you: think about the stuff you like and forget the stuff you don't like. If I'm home, my #1 teammate is my wife. I showed you a picture. If I'm home brushing my teeth and I say to myself, Leslie didn't take that package to the post office that I asked her to. The minute that goes through my head, I say, I'm not going to think that. She's my #1 teammate. Boy, she made some great dinner last night, and the breakfast this morning was wonderful. Just forget the fact she didn't take the thing to the thing. Think about this. Your mom and dad are your best teammates. It's easy to get mad at them. They're not. They're the best teammates you'll ever have in your life. They're the only ones that would work and give you money to go to school here. I'll tell you this. Your best friend on the hockey team, he won't. It's not his job. So, but think about it. Most people are mad at their parents, are mad at their brother and sister. They're the ones that are the best to you. They're your number one teammates. Anyway, you don't want to hear that. Al Shepard hitting the golf ball. Here's me, Pete throwing me a football. I didn't do that. We didn't think of it. But when Al Shepard hit the golf ball, I said to people, why didn't we think of it? He says, we don't play golf. I said, well, we like football. Right, we could have taken the football. We didn't. But as an artist, I did it. That's what the earth looked like. That big. That's a long way off. When I was on the moon, we know that historians, particularly biblical historians, think the Garden of Eden was around the Tigris-Euphrates River Valley. Great. I don't think that anymore. Since being at the moon and looking back, I think the whole earth is the Garden of Eden. We get to live our whole life here. Remember I said what the moon was like? Nothing ever moves on the moon. It's all gray dust, gray rocks, black sky, no wind, no weather, no change. Mars has a little wind maybe. Venus is cloud covered, probably underneath like Mars. The only place that's wonderful that we know of is here. We get to live our whole life there. I love this place. I love this place a lot more than I ever did before I went. I remember looking out the window when we landed in the water before we got out in the raft. I looked out the window and I saw the ocean move. And I said, wow, that's beautiful. And then I said to myself, what's the big deal? We're in the middle of the Pacific Ocean. I've never said that before. And then I thought, you know, I was away 10 days. And then, that 10 days, I never saw anything move but the three of us and our two spaceships. Nothing else ever moved. So I look out the window, nothing was colored, everything was gray, except our spaceships and us. And I look out the window, and here's the blue ocean. I looked up, here's was sky, clouds, fluffy clouds. Over there was an aircraft carrier coming close. We live, let me back up one if I can. Yeah, I can back up to there. This might be a good place to answer any questions. If you've got some questions, I'd be glad to answer them for 2 or 3 questions.
Yeah.
Then I've got one more slide.
Could we just have the lights put it, please? Any questions? One question down here.
What does the moon smell like?
He said, what does the moon smell like?
When you're in your spacesuit, of course you can't smell anything because that environment is away from the moon. And you can't smell it outside, because that's a vacuum and you would die. So when you get back in and repressurize the limb, you've got dust around from the moon and you've got the rocks. And what it smells like to most of us is like gunpowder that's been exploded, or fireworks, or something like that, but very faintly. My opinion is probably when these rocks get inside the lunar module and we repressurize it with oxygen, they become oxygenated just like fireworks do, or explosive. They get oxygen there, and I think it somehow makes that smell. That's the only thing we know. It's not much, but you can kind of smell it.
One up on the balcony.
How were you able to eat?
How are we able to eat?
They thought on the zero gravity part of the flight from Earth orbit to the moon and around the moon, zero gravity, they thought initially before we flew Mercury and the like, and the Russians flew Yuri Gagarin and the like, that maybe humans couldn't eat, maybe they wouldn't be able to swallow. But of course other people said sure they will, because their muscles in their throat and everything long muscles will move the food down. And it did. So in zero gravity we were able to eat everything. If we weren't careful with our food, you'd make a mess. If you wanted to take a little spoon of something out of a bag, if you took it out too fast, and when you stopped, the food would keep going. But you quit doing that because it made a mess you had to clean up. And so you pull it out of the bag real slowly and just put it in your mouth and eat it. So it just takes more time, and if you don't put the spoon back and Velcro, it floats off, and then you wonder where it went. So there's a different way to live at zero gravity than here on Earth. 1/6 gravity is just like on Earth.
You were obviously in training when Apollo 11 went up, and that must have been fantastic for you to witness. But what was the most significant thing about Apollo 11 that changed your flight or your whole experience?
Well, there was nothing huge that did. What happened was, don't forget, we had built up to this. We had Apollo 8 go around the moon. Then we had Apollo 9 work the command module and the lunar module together in Earth orbit. Then we had 10 go around and rehearse the whole thing. Each time we'd get back from a mission, the crew would debrief us for a day or so and tell us what they thought different from when they went, because we were all learning the same thing together and what they found out. And as we walked away from the briefing that Apollo 11 gave us, we knew we were going to be next, then Pete, because we all were doing the same thing, we were trying to figure out how to do this. And so Pete said, as we were walking away, he says, well, we got to get our checklist. We need to change how we get into the lunar module. We need to change how long it takes to do such and such. All these things. And I said to him, well, we already figured that out. He said, yes, but they came back and they did it, and they said it was different. It took longer or whatever it was. And so we just changed to what they said we should change to. And that's the way we kind of moved forward. And then when we came back, we told the next crew, Apollo 13, what to do. They had a problem and didn't land. But we built on each other. We had ideas. We tried to test them on Earth, and then finally we took them to the moon. Some things worked pretty much. Nothing was that far away from what scientists and we had imagined them to be. It was mostly a timing thing, how long it would take. We didn't have to change any basic elements we were doing. It never did in any of the missions, because we used our pinpoint landing technique here. Apollo 11, for example, when they landed on Sea of Tranquility, they landed within a 4-mile radius of a spot. We didn't even bother figuring out where it was, but we knew it was somewhere in a 4-mile radius circle. They said to us, you got to land near that surveyor. And that's a lot closer because you can't walk 4 miles. And so we worked with Mission Control and came up with a way, mostly Mission Control did, where we could land near it, pinpoint landing. It was one of our goals. We could land it on top of it if we wanted to. And that was mostly them. But we made a lot of changes to do that. And then we then showed that to the next crew and the next crew. So it's a building process. It's hard to look back and realize how much we didn't know. Because as we got near the end, 15, 16, and 17, landing was just do this and you'll get there. Now we want you to concentrate on the geology there. And that's what they did. Instead of worrying about how they're going to land and get back and rendezvous, we figured that all out. Now they had to do the geology.
one more question just then.
What was it like when the rocket got struck by lightning?
By lightning,
Yeah, it's
we got hit by lightning in launch. And when you launch, the only person that's got a window is Pete Conrad. All the other windows are covered because we don't have control. Pete did. He was the commander. And so when we get hit by lightning, Pete Conrad didn't know it. Dick Gordon didn't. I didn't. But I had most of the systems, and more warning lights came on than I'd ever seen in simulations. We'd been trained well enough in simulations so that when any failure occurred, like let's say main bus A shorted, I would look up there and see which lights would come on, and I'd say to myself, that's a main bus A short, I need to stick with B, and I need to put AC1 over on B, or whatever it was. Know it. When we got hit by lightning, it disconnected all 3 fuel cells, which we didn't think could occur, did some other things. It illuminated more lights than we had ever seen in our life in the simulator with everything. And I would say we didn't know what to do. We didn't know what the failure was. Now, one thing you learn as a test pilot, if you have a failure of an engine or something, an airplane or control, if the airplane's still flying and going the direction you want it to go, don't do something quick. A lot of people have had an engine failure of the right engine and shut down the left engine. When you're in a kind of a panic situation, it's easy to make that kind of mistake. So we didn't do a thing. We knew that we were headed up and in the right direction. So we had a moment to figure it out, we hoped. And we didn't have any better ideas. And then Mission Control came up and gave us a suggestion to put on the fuel cells. But I, from flying airplanes and everything, I said, maybe that's a good idea, maybe it's to myself. No, maybe it's not. I'll put one of them on. And if it'll stay on, okay. And then I'll put the next one on and kind of build it up so that we don't do some sort of massive other failure that takes out all our electrical system. And that worked. And so we went on. It was an exciting time. I would say I didn't have any fearful thoughts. It was mostly kind of embarrassing because I didn't know what to do. I'd been trained for years, and here's this failure, and I'm not sure what to do. Worked out, thank goodness. Let me just go ahead, one more slide. We're up. Oops, let me back up. We're on the way home from the moon. Pete and Dick and I are about halfway home, 125,000, 120,000 miles away. We're looking out the window, looking at the stars and the sun and the moon is getting littler and the earth's getting bigger. And Pete or Dick says, you know, we're so small here that even with the best telescopes on Earth, they can't even see our command module. We're invisible to the people on Earth. And if there were people on Mars, which we don't believe there are, they couldn't see. In fact, nobody in the universe could see us. We're so small. But here we are, halfway between the Earth and the moon, and we can see all of that. We can see the sun and the moon and all the stars. It shows how small humans are, how inconsequential humans are. And I floated under the couch that night to go to sleep, and I was thinking there's something wrong with thinking that way. That's true, but there's something wrong with thinking that way. So I got Pete and Dick up the next morning, and we looked out the window, and I said, now look, there's the Earth over there. If we had the right computer program, we would know exactly where it's limited to be by gravity and velocity 10 years from now. Exactly. We know where the moon is, that we left a day or so ago. We know where it's limited to be 100 years from now. The sun, 1,000 years from now. Those things we can see. Every one of these stars is limited to where it's going to be 10,000 years from now. It's going to be there or there. That's it. The only thing in the universe that we know of that is not limited in that way are human beings just like us. Now, maybe they're human beings, some sort of beings out around other stars, on planets like ours. Maybe so, who knows? Maybe we'll find out someday. But, as far as we know, the only entities in the universe that have been given the gift of unlimited potential, unlimited as to what we'll do in the future for us. And this is true for everybody in this room. The only limits on you, what you do in your life are the ones you place on yourself. Now sometimes you listen to other people and they place them and you believe them. Big mistake. No one knows. No one in this room, including the professor here, has ever taken a test that tells what you could do in the future. None. You may be an average guy. I wasn't the smartest guy in my class ever. But I kept at it. No one would have ever guessed I would end up on the moon. I'll tell you that. But if you keep at it, and you don't believe them, and you keep working towards your goals, whatever they may be, and keep at it again and again, be nice to other people. Like I said, care about them, work with them. You have no idea. There's no one in this room that knows how great they could be in 10 years if they did that. No one in this room knows how great they could be in 20 years, 30 years. You don't know. You can't know. You have to do by faith. You've got to get up every day and say, I'm going to do the best. I do this every dang day. I get out of bed in the morning, I get up at 4:45, I say, what can I do to be as great as I can be today? It goes through my head every single day and during the day. It needs to go through yours. If it goes through your head, that doesn't go through everybody's head. That's how I got to do this stuff. It went through my head, and I kept getting a little bit better and a little bit better. I was never, ever the best art student in any of my art classes when I was taking art 30 years ago. I will bet you right now, I'm by far the best artist of any of those people, because I kept doing it day after day after day. You can do it. You can do it, but no one else can do it for you. Only you can do it. That's the great equalizer on earth. Some people are born tall. Some people are born running fast, stronger. Some people's IQ is better than yours. Some are better looking than you are. You wish you could be like them. I did spend a lot of my time wishing I could be good looking like some of my friends. I never was. I was the same old guy. But I could work hard every day and pass some of my friends. Not all of them. If there was somebody smarter than me and he worked as hard as I did, I couldn't pass him. But most people don't work hard. That's why it's a great equalizer. Persistence, caring, working hard, getting along with people, being nice to them, not playing dirty. Doesn't work, in my opinion. Anyway, let me leave you with 3 wishes. In your life, you're right on the edge. You're just blessed to be in this school and have this parents that have supported you here and will in the future. Light to thy path, wind to thy sails, and dreams to thy heart. I'm glad to have been with you today.